Hello, everyone. Starting chapter 2 here. The theme of chapter 2 is basically how many different ways can we do something. Depending on how the question is phrased, there's a few different ways that we can figure that out. And so we're going to go over our first couple methods today. Um, but that's the tricky part with that we'll find in chapter 2 is that the way that something is phrased can really change how we approach the problem. And so we really need to pay attention to that. And throughout chapter 2, I'll kind of focus on some of that vocab. Okay, so hopefully you have your notes in front of you. If not, I would jot down this problem here. The first method we're going to go through is called a tree method. Which we'll find out isn't really the most effective way to do this, but then it'll at least give us some reason on to why the shortcut works. Okay, so it says when Tom is making a sandwich, he has some serious decisions to make. He has to decide between wheat or white bread, between ham, turkey, or salami, and between American or provolone cheese. How many different types of sandwiches could Brandon make? Okay, and so what the tree method tells us is you basically make a tree diagram for every possibility. So for example, if he is going to start with a wheat bread. And then he has to choose from ham, salami, or turkey. And then from there, he has to choose, if he does ham, then he's got to choose from American or provolone. Salami, he has to choose from American or provolone. Turkey, he has to choose from American or provolone. So what we're doing is the wheat part is, in this case at least, is kind of like the trunk of the tree, and then we have different branches that go out. And ultimately, what we're going to count is the final number of possibilities. And so just with a piece of wheat bread, he could make 1, 2, 3, 4, 5, 6 different types of sandwiches with just wheat bread. Could be wheat with ham and American, wheat with ham and provolone, salami American, salami provolone, turkey American, turkey provolone. But then the same options happen if we decide to go the white bread route. We have ham, salami, and turkey. We have American and we have provolone. We have American and we have provolone. We have American and we have provolone. And so we end up with 6 more options, which would give us a total of 12 ways that you could make a sandwich from these options. Again, this is our tree diagram, where at the end you basically count the number of leaves that you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different ways to make that sandwich. Let's go over one more and then we'll find a shortcut. You have a couple choices when you want to order popcorn at the movie theater. You can either go small, medium, or large. Then you can have butter or no butter. Then you can have salt or no salt. Draw a tree diagram to determine how many different ways there are to order a bucket of popcorn. And so again, the different sizes are kind of your roots here. So you could do a small, a medium, and a large. Then from there, you could decide to go with butter or no butter. You could go with salt or you could go with no salt. You could go no butter with salt. You could go no butter with no salt. Okay, and then the same options exist for medium and large. Butter, no butter. Salt, no salt. No butter with salt, no butter, no salt. Butter, no butter. Butter with salt, butter with no salt, and so on. We count the number of branches. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so in this case, there happens to be 12 different ways to do that again. Okay? But there's a quicker way. Okay? If we look at the number of options, we had 3 sizes. We had 2 different types of butter, either butter or no butter, and 2 different options with salt, salt or no salt. 3 times 2 times 2 is 12. If we go back up to our sandwich example, we had 2 different types of bread. We had 3 different types of meat. We had 2 different types of cheese. 2 times 3 times 2 is 12. We call this the fundamental counting principle. Fundamental counting principle. fundamental counting principle says if there are A, quote unquote, ways to do one thing, and B, quote unquote, ways to do another thing, the total number of possibilities is A times B. And if we, in that general example, you only have two things to choose from, but that works as we saw with the popcorn example. If you're choosing one thing from different groups, we use the fundamental counting principle. Okay, and that's how you really think of that. Choose one thing from many groups. Okay, that's when you use the fundamental counting principle. So again, you really have to focus. I know we only have one type of problem right now, but these little, these little things that I write out here are going to be what's helpful as we get more methods. We have to be able to read a problem, kind of think about how it's worded, and say, oh, this I'm going to use the fundamental counting principle because I'm choosing one thing from different groups. Okay, so let's use that shortcut one more time. What are the possible number of ice cream sundaes that can be made if there are 5 flavors of ice cream and 4 possible toppings? Again, we are just assuming here that we are choosing just one of each, one flavor, one topping. So 5 times 4, there are 20 different ways that you could make those sundaes. Okay, so that's the fundamental counting principle. Now there are variations of this principle that we'll go over in a little bit, but let's just go through another couple examples here. So suppose we had a die and a deck of cards. How many different situations can occur when one die is tossed and one card is picked? Again, focusing on the wording here, one die and one card. When you roll a normal die, there are 6 different options. There are 52 cards in a deck. So 6 times 52, 312 different outcomes there. Okay, 312. In Minnesota, a license plate consists of 3 letters and 3 numbers. The letters and numbers on license plates can repeat. Okay, can repeat. Something that we kind of talked about a little bit in chapter 1. How many different license plates can be made? So as we're going to see on the next page, sometimes drawing pictures can be really helpful here. So I'm going to draw, and when I say a picture, it's not kind of like your normal picture. It's going to be, I'm going to use kind of lines here. So I'm going to take three lines to represent the letters A through Z. Because on each line, you could have 26 different letters, and they can repeat. And then I'm going to make 3 more lines, and that's going to represent the numbers 0 through 9. Those digits can be on your license plate. Careful there are 10 digits, 0 through 9. Don't get thrown off by that. And so I am then going to, again, fundamental counting principle. I proved it to you. We always multiply. So I'm going to multiply because each time you are in this slot, you are choosing one letter from a group. You are choosing one letter from a group. One letter from a group. One number, one number, one number. So I'm going to multiply straight across. When I do that, I get 17,576,000 license plates. If you've ever paid attention, you can actually, like in this picture that they show us, XVZ158 is one license plate number. There is somebody else out there in the world, out in Minnesota, I should say, that has the license plate 158XVZ. So they can flip, and those are different license plates. And so in actuality, if I multiply that by 2, since every license plate can be flipped, there are actually 35,152,000 license plates, different license plates that can be made. And that doesn't include, you have the Boundary Waters license plates and different things like that. So that doesn't include those types of license plates. But it just, for your normal standard, there are 35 million possibilities over that. Okay? Again, in both of these examples, you're choosing one number from the die, one card. So you just do 6 times 52. One letter goes in each spot. You can repeat. One number goes in each spot. And so you just multiply the number of possibilities. Okay. Some variations of the fundamental counting principle, and this is where those, again, I call it pictures, but you're not necessarily drawing, but you're using those lines. It says a math quiz has 6 true and false questions. So how many different possibilities are there to answer those 6 questions? Well, you have 6 questions, so I'm going to draw 6 lines. 6. And in each question, you have 2 possibilities. For question number 1, it could be true or false. For question number 2, it could be true or false. True or false, true or false, true or false, true or false. This doesn't really have a name. I call it the exponent method. It really is just a variation of the fundamental counting principle. But there are 2 to the 6th ways. There are 64 ways to get that right. Now, something may or may not be an extra credit test question on your Chapter 2 test is what is the probability that you get 100% on this quiz? Well, think about it. If there are 64 different ways, there's only one way to get them all right? There's only one answer key. So there is only 1 out of 64, which if I take my calculadora here, would give me about a 1.6% chance of getting 100%. So think about that. You go into a math quiz and you're like, oh, true and false, it's only 6 questions. That's going to be easy. Well, if you were just to randomly guess, you would have less than a 2% chance of getting 100% on that. Okay? But just keep that in mind. May or may not be an extra credit question on your test. It is something very similar to this. A math quiz has 4 multiple choice with options A through D. So in this case, there are 4 questions. Again, each one has 4 options, A through D. So 4 times 4 times 4 times 4. 4 to the 4th power would give us 256 different ways. Okay, here's one where the wording is going to be an emphasis. It says a pizza stand offers both hand-tossed and pan pizza. Now again, you're only going to choose one of those. So that's where it would lead you to think, okay, fundamental counting principle. Customers can add any combination of 5 available toppings. I want you to circle that like I did, because we're going to actually take a note here quick. Again, the wording in Chapter 2 is very important. You have to pay attention. It says any combination of 5 available toppings. So keep that in mind that you could have 0 toppings. You could choose that, 0 toppings. You could have 1 topping. You could have 2 toppings. Or you could choose all 5 toppings because it's any combination. Okay, so here's what that would look like. So a pizza stand offers both hand-tossed and pan pizza. So for that part, again, you're only choosing one of them, so there's 2 options. But then for this part, any combination of 5 available toppings. There's 5 toppings to choose from. Oops, sorry, got cut off. There we go. There's 5 toppings to choose from, and for each one, you could say yes or no. So for each one, there are 2 options. Yes or no to the first topping. Yes or no to the second topping. Yes or no, yes or no, yes or no. And so here's the part that's tricky, is that if you read it quickly, you're thinking, oh, 5 toppings, 2 times 5 is 10. But because it says any combination, meaning that you could choose 0 toppings, but you could also choose all 5 or something in between, it becomes a 2 times 2 times 2 times 2. In other words, 2 to the 6th power. So a lot like the first one, you end up with 64 different possibilities of pizza there. Okay. Again, emphasis on that phrase, any combination, meaning you could have more than 1 topping, or you could have 0 toppings. Last one. A football player attempts 5 passes in overtime. Each pass attempt results in a completion, incompletion, or turnover. Again, there's 5 passes. There's 3 possibilities for each pass. So 3 times 3 times 3 times 3 times 3, 3 to the 5th power, 243 different possibilities. Okay. So this is your fundamental counting principle. That is learning target 2.1. Okay. Again, just make sure you're really focusing on the wording of the question. I would draw those pictures. That's going to be helpful. Again, pictures meaning like using the lines, and then on each line write how many possibilities there are. Okay.